Hello, so right now I will start the chapter 5, which is the one that I'm most familiar with because it's about pandas. So let me share my screen with you and let's start. So right now we will go to the chapter 5. And the first thing is series. So in series, actually, series is one-dimensional array-like object containing a sequence of values and an associated array of data labels called its index. So the series is like this: pd.series, and then okay, 4, 7, 8, 9. Okay, we didn't import pandas. Let me do it. Import pandas as PD. Serious. Okay, it's upper level. Okay, let's go to the next part, which is a string representation of a series displayed interactively shows the index on the left and the values on the right. Since we didn't specify an index for the data, a default one consisting of integer 0 through n-1 is created. You can get the array representation and index object of series through its values and the index attributes. So we can get obj.values and obj.index. Okay, so that's what we can get. Often it will be desirable to create a series with an index identifying each data point with a label. So obj2 is equal to PD series, this one, and then we have index, which is equal to, okay, A, B, C, and D. So this is object 2. So right now obj2.index, this is what we can get. So compared with the NumPy arrays, we can use labels in the index when selecting single values or a set of values. So here is what we can get. We can get here is, okay, let me change my input input method, and okay, see. So the next thing will be, okay, we will using NumPy functions or NumPy-like operations such as filtering with a Boolean array, scalar manipulation, or applying my functions will preserve the index value link, right? But right now we can do it we can do the filtering like this. obj2, which is bigger than 5. So these are all the things which is bigger than 5. And what we can do is also, okay, we can multiply it by a number. And I think object 2 itself is not changed, right? I think it's not changed. Yeah, it's not changed. And so another way to think about a series is as a fixed length ordered dictionary, as it is a mapping of index values to data values. It can be used in many contexts where you might use a dictionary. So for example, I want to know B in obj2 and how E in obj2 is false. Then so when we have data contained in a Python dictionary, we can create a series from it by passing the dictionary. So that is, okay, we have this dictionary and A 10 B, which is equal to, okay, key is B and the value is 9. So let's check, okay, obj3 is equal to pd dot series and parenthesis as data. So obj3, that's what we have right now. We turn dictionary to a series. So when we are only passing a dictionary, the index in a resulting series will have the dictionary's keys in sorted order. We can override this by passing the dictionary keys in the order we want them to appear in the resulting series. So how can we do it? So right now, okay, right now I have what I want the index is to be A, right? And so I create another object, which is object 4, and then I want to do is index is equal to, okay, is equal to index. Okay, I don't want to, it's high, okay? So make it clear. So what's in object 4 is that right now the order is changed. You can see that here. So 3, I mean, we can see, okay, the appropriate locations are assigned here, right? So if there are any, for example, if we put C in this index list, then if no value for that C was found, so it appears as NaN, which is considered independent to make missing or NA values. So for example, let me put it here. Okay, yeah, that's what happened. So we will use the term missing or NA interchangeably to refer to missing data. But is now and not now functions in pandas should be used to detect missing data. Yeah, that's what we do a lot. pd.now is now obj4. So we can see the last one is non-value, right? So is none, not none. And the next thing we want to check is, okay, obj4 not none. See, so that's correct, right? Okay, a useful serious feature for many applications is that it automatically aligns by index label in arithmetic operations. So how to understand this is that, okay, if right now we have two series and we want to add them together, and at the same time, so maybe their index are not the same, but when I add them together, actually they can automatically find the same index, which I think is very interesting. So let's check. Okay, this is object 3, this is object 4. So I want obj3 and obj4 together. So what you can see is that, so in obj3, its value is 10, and in obj4 its number is also 10. So it add them together to be 20, right? So this is funny. So data alignment features will be addressed in more detail later. If we have experience with databases, we can think about this as being similar to join operation. Yeah, I've never saw this before. I think it's very interesting. And at the same time, both the series object itself and its index have a name attribute, which integrates with other key areas of pandas functionality. So what we should do is that, okay, let's check. OBG for name. Okay, what we assign something to it. It equals to a people ID. Okay, then we will look at OBG index.name. Okay, the index.name is not its customer. Then what happened to object 4 here? So right now we have yeah, we can see the name is ID and the index name is customer, right? So that means both the series object and the index, we can assign a name to them. So series index can be altered in place by assignment. So let me see. Okay, I want to change ABC. Okay, this, for example, this result OBJ5. So I want to change this list of this one. So dot index equal to D E. Right now we can see, okay, our index is changed. So a data frame, the next part I will check is data frame, which is the part I'm quite familiar with because I will work with it every day. Data frame represents a rectangular table of data and contains an ordered collection of columns, each of which can be a different value type, right? Can be numeric, string, Boolean. The data frame has both a row and a column index. It can be thought as a dict of series or sharing the same index. Then under the hood, the data is stored as one or more two-dimensional blocks rather than a list, dictionary, or some other collection of one-dimensional arrays. The exact details of data frames internals are outside the scope of the book. Okay, but actually I should to know more about this because data frame is very important for the data science. And so the first thing is to create a data frame, and I will go to steal some people's like data frame creation code, so I don't need to create it by myself. So let's start. Actually, here is one, but it's not that duplicate. It's not that complicated. So maybe let me find something interesting. Okay, that because I'm lazy, so I do not want to create a big data frame by myself. And okay, I got one, so I will put it here. And so this is a data frame I create, somebody create, and I copy paste. So this is a data frame, and the result will have its index assigned automatically as with series And the columns are placed in sorted order. So we have index here, which is 1, 2, 3. And we are using Jupyter Notebook. Yes, we are using Jupyter Notebook. So data frame objects will display it as a more browser-friendly HTML table like this. So for large data frames, the head method, okay, we can use head to find just the first 5 rows. And at the same time, we can arrange we can also, if we want to specify a sequence of columns, the data frames columns will be arranged in that order. If we pass a column that isn't contained in the dictionary, it will appear with missing values in the result. So how to understand this is that, okay, right now we have a column, if we have a column name, and but we don't have that anything in that column, and we will still have that column, but the values under that column actually is just a none. So for example, like this, we have, I want to put age in front, and I have name, and then I want, okay, gender, right? So I have gender, but gender is all non-values. And the next step is that a column in data frame can be retrieved as a series, either by dictionary-like notation or by attribute. So yeah, that's how you get. You can find a column like this, and you can also do like this. So this is pandas, and the next part is that, okay, so rows can be retrieved by position or name with a special log attribute. So this is a log attribute. So for example, first, okay, df.log and 0. So what I find is the first everything in the first row. That's how I get it, because actually the number in the log is the index. So columns can be modified by assignment. For example, some empty value. Yeah, I have empty value here is gender. So gender can be assigned a scalar value or an array of values. So for example, okay, df gender. So if I know all of them are boys, so I will say male. Then we can see what happened to gender. Okay, they are all male. And so yeah, that's how we do it. And the next part of the data frame is that when we are assigning lists or arrays to a column, the values length must match the length of data frame. If we assign a series, its labels will realign exactly to the data frame's index, inserting missing values in any holes. So how to understand this is that, okay, right now we have a series, which is pd.series, and then we have some value, which is female, and female. Then we have the index, which is equal to 0, 2, 3, right? And then what happened is that df gender is equal to val, Then what happened? See, right now we change the we change the first one and the third one, the fourth one's gender to be female, and because we don't have any value to assign to the second value in gender, so it is an IN, which is non-value. So assigning a column that doesn't exist will create a new column. The DEL keyword will delete columns as with a dictionary. So let's use the, let's create a new column first, which is job. So we know that they are all teachers. So teachers, and let's see what's in there. Okay, that sounds great, right? So and also if we want to delete this column, leave df job. So in df, okay, we delete that column. So the column returned from indexing a data frame is a view on underlying data, not a copy. Therefore, any in-place modification to a series will be reflected in the data frame. The column can be copied with a series copy method. So another common form of data is a nested dictionary of dictionaries. So first I need to find out, right? I need to find some a nested dictionary. I'm so lazy. So nested dictionary. Okay, give me an example, then it will be great. So this is a nested dictionary, and okay, it's like this. So let's check what it looks like. Okay. Wow, it's too complicated, right? So, and we have key. This is the key 1, 2, 3, and in the key and in the value of this 3, you can see there are another dictionary. So what will happen if we use PD data frame parenthesis DICG frame 3? Okay, what a frame 3 looks like. So everything in, because everything in 3 and any of the values in 3 is a dictionary, and there are 3 of them. So everything before, every key before it also have 3 values, duplicate values, and also the you can see that the index is changed to here A, B, C. So we can also transpose the data frame, which is frame 3 dot T. Okay, that's what we can get from here. So the keys in the inner dictionaries are combined and sorted to form an index in the result. This isn't if an explicit index is specified. And so yeah, so what we can do in frame, it looks like this, right? Right now we want some new index, which is, for example, PD dot data frame, right? And we want to take the index dictionary index is equal to B, A, T. See, so we only get what we have, and for others it will be none. So dictionary of series are treated in much the same way. And also for a complete list of things we can pass the data frame constructor, what we can check is, for example, the dictionary of arrays, of dictionaries, list of dictionary or series. There are many things that we can pass a data frame constructor. So if a data frame index and columns have their name attributes set, these will also be displayed. So yeah, we can actually assign the index name and also to create columns name to a data frame. So for example, for frame 3, then frame 3 dot index dot name is equal to no name. So what will happen here? Okay, see, it's no name, and the columns dot name is equal to number. So what about frame 3? Okay, like this. So as with the series, the values attributes returns the data contained in data frame as a two-dimensional ND array. So for example, frame 3 dot values, we can get everything actually in filled in the rows and columns, each value. So if the data frames columns are different D types, the D type of values array will be chosen to accommodate all of the values. So that's all for the data frame right now. And in the next part, I will talk about index objects. And I will talk about essential functionality, which is re-indexing and dropping entries from an axis, and indexing selection and filtering, and integer indexes. Okay, that are all the contents for next video. So I'm checking actually a whole chapter. So I think I can finish this chapter in, I hope in 3 videos. So this is the first one. And so let's continue in the next video. Thanks for watching. Bye.